had to connect to certain things to get its job done. And those were not bugs that could have been swept under the rug. But the other bugs that were in the user interface and the load engine, in other words, that had to do with the way this application did its work, those are all really kind of questionable as to whether those were real bugs or whether those were just enhancement requests of, change this in the system, change that in the system. So you notice I did a Pareto analysis here, and you see that 70% of the bugs are load engine or user interface. In other words, they are of a certain questionable reality, questionable basis. We can be skeptical about whether those were really bugs or they were requirements. So I wasn't about to go quarreling through all 900 plus bug reports and try to separate out which ones should have been requirements, or should have been enhancement requests, and which ones should have been real bugs. But I figured this was could give me kind of a nice little lower bound. I mean, I know that there's a certain number of bugs that are out there. So basically, that number of bugs that just had to be fixed is 30%. The ones that weren't user interface and load engine. Well, if I go back here, remember I said 6 weeks. So 1, 2, 3, 4, 5, 6. That was the original plan. Now let's say that 900 bugs is where this was ultimately settled at, or just use that as a kind of a kludge. So that means that 30% of 900 bugs is 270 bugs that really did need to be fixed. So there's 100, 270. And notice that they fixed fully 130 bugs above that. So of the other bugs, the 560 bugs that were reported roughly, 500 and so bugs that were reported roughly, is it possible that 130 of those were real bugs? Yeah, I'd buy that. More than 130 of those real bugs? I don't know. There was a lot of redefining what the requirements were. So what does that mean? Well, what that means is if these guys had focused on only talking about real bugs, in other words, if they'd done a better job of triaging the bugs, they could actually have focused on what probably the 400 or fewer bugs that were inherent in the system, had to be fixed, and could have succeeded. So no, indeed, this is a situation where the failure of the project was certainly not inherent in it, but rather was associated with a lack of good software engineering practices on the part of the team. And then finally, a final little note here about haste makes waste and other cliches that are cliches because they're true. This is the reopened count. Now, the way the reopened count works is very simple. Their bug tracking system had a really nice feature, and if yours doesn't have this, it suggests that you add it. Every time you open a bug for the first time, it sets the open count to 1. Now, if you get a bug fix back, and you confirmation test it, and it fails the confirmation test, then you reopen the bug, and the act of reopening the bug increments the open counter. So it goes up to 2 or 3 or 4, or whatever it goes up to. It just keeps getting incremented every time the bug's reopened. Now, if you close the bug, then it doesn't get incremented. But if you subsequently later reopen a bug that was closed, then that will indeed increment the counter again. And we can use this to try to figure out how much waste was really inherent in this crazy, got to turn around the bugs overnight in spite of the technical debt. What did that do to them? Well, let's assume that every time you deal with a bug report, and I say you, I mean the project team deals with the bug report, it loses a person hour across the tester and the developer and the configuration management people and so forth, person hour of lost time. Okay, so here's 112 hours. All right, here's 52 hours because this one was open 3 times, so that's 2 reopened. So 2 times 26 is 52, so 164 wasted hours plus 18. So now we're up to 182 plus 20. We're up to 202 plus 10. We're up to 212. That's a lot of lost person hours on a project that was supposed to last 6 weeks. I mean, that was basically the same as throwing away one person effort over that 6-week period, right? So this is a real drain. And basically, if you look at this, 83% of the bugs were fixed the first time. That means 17%, or fully 1 out of 6 bugs, was reopened. And just to give you a hint, in our assessments, we typically say that 5% is a logical upper bound for this. If you get above 5%, you're flirting with some kind of potential disaster. Okay, so what are, just to kind of wind this down, what can we conclude about some best practices in test reporting? What are good things to do most of the time when we're doing test reporting, which, by the way, is what a best practice is, good things to do most of the time. So deliver useful, credible, timely information. Very important. We don't want to be delivering useless information, because that's wasting everybody's time. We need to be credible, because if nobody believes us, then we are, again, wasting time, ourselves, and our own time and others. And it needs to be timely. There's no trick to predicting yesterday's weather. People don't be interested in that. You want to give people information at a time when that's what they needed to know. It's something that they can act on. As I said at the outset, tailor your presentation to your audience. Make sure that the people you're talking to them at the right level. If you're talking to a non-technical audience, don't go off into the technical weeds. If you're talking to a technical audience, then you can get into technical details. It also might be that you need to bring them to the user's or business person's reality, that they might not be aware of that. So that might be part of your role. So think about your audience. Master your data, master your facts, know what you're talking about. It's very embarrassing to go into a situation where you don't have your facts together, you don't know what you're talking about. Somebody asks you a question and you can't answer it, and you try to answer it. So the worst thing you do there is what a lot of people do, which is try to bluff their way out of it and talk their way out of it. A smart manager will not fall for that. So smart managers, they can recognize when someone's trying to snow them, and then at that point you're going to get drill down questions, and those questions will be designed to reveal that you don't know what you're talking about. And getting back to this question of credibility, there goes your credibility. Okay, keep your cool. Don't get frustrated. Don't let people make you frustrated. Sometimes that can be a tactic that is used. Don't let people do that. The more controversial, the more potentially contentious a report is going to be, the more carefully you have to manage how you deliver that information. One thing is, if you've got some information, you've got a report where it's going to point something out that's going to make somebody in the room look bad, don't ambush that person. Give them that information beforehand. Now, there might be some exceptions to this. Maybe you're going to try to pull off some sort of, three-dimensional political chess move in some meeting and make people look bad. But, my experience with that has certainly not been positive. If you make a habit of making people angry, it's not going to turn out well. Yeah, as a tester, you will often be in possession of dangerous information that can be used to make people look bad. But if you make a habit out of doing that and enjoying doing that, I think you will find that your longevity in organizations is fairly brief. Excuse me. Now, test status is dynamic. Test status evolves. We don't have the luxury of assuming that things are standing still. So, make sure that you understand that evolution and what's going on, and be ready to do some compare and contrast, because people's expectations, well, your expectations will be shaped on a moment-by-moment basis as a test manager. You're immersed in the change, and